Hi guys, welcome to the lecture on microcontroller and its application. Today we'll discuss about the memory organization of 8051. We know that 8051 microcontroller has an internal RAM and ROM. It has an internal RAM of 128 bytes and it has an internal ROM of 4 kilobytes. Now the capacity of internal RAM and ROM is very system specific. It is manufacturer specific. So Intel 8051 microcontroller has this capacity, but as you know, 8051 microcontroller is not only manufactured by Intel, it is manufactured by Philips, by AVR. So they will have their own variable internal RAM and ROM capacities. But apart from internal RAM and ROM, it can also access external RAM and ROM. So internal RAM, it has 128 bytes. We'll see how the internal RAM is classified in 8051. As you can see on the screen, the internal RAM of 128 bytes is basically divided into three basic types of memory. One type of memory are the register banks. As you can see here, there are four register banks. That is register bank 0, register bank 1, register bank 2 and register bank 3. And each of this register bank have 8 registers which are 8-bit wide. There are 8 registers which are each of these registers are 8-bit wide, and they are addressed as you can see here from 00 to 07. And apart from this 8 register banks, you have, apart from this 4 register banks, you have another RAM area which is known as bit addressable area, where each bit can be addressed specifically. This is for bitwise operations like clear a bit or set a bit, an operation which just requires one bit. So such operations can be performed in this memory, RAM memory, that is bit addressable RAM. And then the other area of the RAM, the remaining area of the RAM, that is from 30 to 7F, is actually used for general purpose registers, or it is also called as scratchpad RAM, which is byte addressable, and you have to address them with their memory location address. Okay, so this is basic. Let's see a little bit in detail. As you can see, the memory organization, register banks, each register bank has 8 registers, that is from R0 to R7. So each register bank 0, register bank 1, register bank 2 and register bank 3 have that, and they each registers have their unique addresses. So their addresses are towards the left, as you can see, from 0 to 7 for register bank 0, for 0 to from 8 to F for register bank 1, similarly for register bank 2 and register bank 3. Okay, so this is the memory organization for the bit addressable register area, bit addressable area. Now, if you see the bit addressable area, you have around 16 bytes of bit addressable area. These 16 bytes of bit addressable area, as you can see, each bit in that can be addressed, and the address is given here as you can see on the screen. It starts from 000 to 01, 02, 03, 04, 05, 06, 07. This is for memory location 20. So 8 bits in this register, in this single bit addressable register, can be accessed individually using some instructions, as we can see at my right, using some instruction like set bit. Bit can be maybe a bit in any one of these address locations. You can say 20.00, 20.101, 20.02. It will set or clear or complement or jump to a bit. It depends upon a bit addressable instruction. You can access a particular bit in a bit addressable area in 8051. Apart from this bit addressable locations, the remaining locations are covered by your general purpose registers, that is from 30 to 7F, which can be only accessed by their memory location address. So basically, as you can see on the screen, there are 3 types of internal RAM. The internal RAM is divided into 3 types, that is 32 bytes are your register banks, and then you have 16 bytes of bit addressable registers, and then you have the remaining around 80 bytes which are byte addressable only by their memory location. So this is what classifies the internal memory. Yes, now let's see the memory organization, how to access external memory using your 8051. As I said, internally only 128 bytes of RAM and 4 kilobytes of ROM. So if you want to expand your RAM and ROM capacity, you have to go for external memory units. So how would you access external memory units? As you can see, The most important, the first step to access external memory, that by which you tell to your microcontroller that you have to access external memory now and not internal memory, is by grounding one pin called as external access pin, which you can see at the left. EA, if you ground this pin, which is, it is an active low pin, external access, if you ground this pin on 8051 microcontroller, the microcontroller 8051 automatically understands it need not access its internal memory anymore, it has to access its external memory. So this is the first fundamental step that has to be completed. The next step, you know, your address lines and your data lines are present in two ports, port 0 and port 2. In fact, port 0 houses the multiplex address data lines and port 2 houses the individual address lines or the dedicated address, higher order address lines. So port 0 pins are multiplexed with address data lines multiplex, that is AD0 to AD7, and port 2 is port 2 houses or has a multiple function of address lines 8 to address line 15. So that is how it is classified. Now these address and data lines are used to access your RAM and ROM. And as you would know that number of address lines directly dictates how much of memory location your 8051 or any microcontroller processor can access. 8051 has 16 address lines. So since it has 16 address lines, you know very well it can access up to 2 power 16 memory locations. So since it has 16 address lines, it can access around 2 power 16 memory location, which is around 64 kilobit. It's around 64 kilobyte of memory location. So you can access around 64 kilobyte of memory location using 16 address lines that are available on 8051. And by default, when you interface your microcontroller 8051 with any memory unit, all the data lines will be connected to its RAM or ROM. So here we see an effort to interface a 16 kilobyte ROM and an 8 kilobyte RAM memory. Now as you can see, a 16 kilobyte of ROM and 8 kilobyte of RAM can be simultaneously attached to your 8051 microcontroller. Now up 16 kilobyte of ROM, how many address lines would 16 kilobyte of ROM require? Well, if it's a puzzle for you, just remember this simple formula: 10 lines can provide you access to 1 kilobyte of memory location. 10 lines. So 11 lines can provide you double of that. That is, 11 lines can provide you up to 2 kilobyte. 12 lines can provide you double of that. That is 4 kilobyte. 13 lines can provide you double of that. That is up to 8 kilobytes. So 14 lines will provide you up to 16 kilobyte of memory access. So as you can see over here, there are 16 kilobyte of ROM which can be accessed by 14 lines. So A0 to A13. So A0 to A13 have to be run to this memory location ROM. So your lower order address lines are multiplexed with your data lines. So they have to travel through a latch, 373 latch, which will demultiplex your address data lines. So all your address data lines multiplex will have to pass through a latch, and this latch is enabled by one signal called as address latch enable. So address latch enable will demultiplex your address and data lines and provide that address lines to your ROM and RAM. So your lower order address lines A0 to A7 are connected to ROM and A8 to A13. So totally A0 to A13 are 14 address lines are connected to your ROM, 16 kilobyte of ROM. Okay. In the same way, now we can say 8 kilobyte of RAM would require how many lines? Half the number of lines? No. It would require one line lesser than that, that is around 12 lines. So A0, that is around 13 lines. So A0 to A13 address lines are connected, A0 to A12 address lines are connected in fact to your RAM memory, which is of 8 kilobytes. So this is a simple procedure of understanding how many lines of address should be connected to your RAM and ROM. Once this address lines and data lines are connected to your RAM and ROM, remember there is one signal called program store enable, PSEN. This signal has to be sent to your ROM to invoke it. So you need to connect this line to your ROM. And the same way, there has to be two lines from your 8051 which has to be connected to your RAM, that is write and read signal. So write and read signal, as you can see here, write bar and read bar has to be connected to your RAM memory so that you can access write as well as read data from the 8051 memory locations accessed by your 8051. So this is how an external memory is interface with your 8051 microcontroller. Always remember, first thing, ground external access pin. Port 0 and port 2 provide you address and data lines. Port 0 provides you address data line multiplex, and port 2 provides you higher order address lines. So connect these address lines to your memory locations according to the capacity of the memory location. So once the number of address lines are fixed, you can send those number of address lines to your memory locations. Once you send number of address lines to your memory location, remember you need a 373 latch to demultiplex lower order address data lines multiplex address data lines. So you have to demultiplex it, and remember PSEN is a signal which you have to send to ROM, and write and read is a signal which you need to send to RAM. So this is a very simple concept of how you externally interface memory. This is the timing diagram of how the operation happens. You know, the address latch enable, which is there is one pulse per machine cycle. That pulse will say when an address has to be latched to your RAM and ROM. And you can see the PSEN signal, which is an active low signal. When it goes low, your ROM is enabled, your ROM memory is enabled. And when read pulse goes low, you can read a signal, you can read a data from 8051 microcontroller. And when write signal goes low, you can write a data into the memory device. So that's how your 8051 microcontroller memory interfacing works. Hope this was useful for you. It was a very simple concept on how to access your memories, internal RAM as well as ROM. Remember, internally 8051 has 128 bytes of RAM and 4 kilobyte of ROM. Externally, it can access up to 64 kilobyte of RAM and ROM. So that covers our lecture on memory organization.